moving to the next problem. Here we are given that A and B are two n by n matrices. Then which of the following equals trace of A square B square? Okay. Here the basic property that we are going to make use is, we know that trace of AB is trace of BA for any two n by n matrices. Okay. Now this is the ideology that we are going to employ here. How can we write trace of A square B square? This may be written as trace of AA BB, right? So treat this A as a separate matrix, that ABB as another matrix, another n by n matrix. So this is trace of A BBA, which is nothing but trace of A B square A. So we got an option here. Okay, this is asked in part B. So if we find the right answer, we can stop here and move on. But if you do it in, if you try to do it in other ways, what are the other ways possible? We have trace of A squared B squared. So this may be written as trace of B squared A square when treating A square and B square as separate matrices. So from which this is one possibility, and the other one would be what? In a similar way, if you consider this B in the first position and BAA and shifting here, whatever you have done for A, done with A, do it with B, then you would get BA square B. This is also turning to be the right option. If these kind of questions are asked in part C, you can very well make use of the ideology. Here, what is the ideology that we have used? Simply trace of AB same as that of trace of BA for any n by n matrices. Okay, only that ideology. And when you have an n by n matrix, when you multiply an n by n matrix with another n by n matrix, you are going to end up with another n by n matrices. So only these ideologies are enough to attempt these kind of questions. Now moving to the next question, it is given that A is any m by n matrix of rank n. Okay, basically rank of a matrix is what? That is the, which is actually smaller than or equal to minimum of, okay, basically rank is the number of independent rows or the number of independent columns. Okay, to the most it can be either equal to row or the column based on the calculation that the minimum of row and column. Okay, so this is the simple information that is given to us. A is any m by n matrix with rank n and real entries. Now we'll have to choose the correct statement. And ax is equal to b. We are going to talk about the solution of this ax is equal to b. Okay, when does it have a solution? If we talk about the solution with the help of a rank, this can be, it will have a solution whenever rank of a b is same as that of rank of a. Okay, here in this problem it is given that rank of a is equal to n, which means your m is bigger than or equal to n. Okay, and again how can we treat this matrix A? This can be treated as a linear transformation from Rn to Rm. So that is, you have basically a linear transformation from Rn to Rm. The associated matrix is A. So these are the ways, or these are the possibilities in which the problem can be dealt. Okay, by rank nullity theorem, what do we have? Rank of, rank of A plus nullity of A equal to n, right? That is the dimension of the domain. Rank is given to be n, which clearly tells us that the nullity is 0. Okay, these are the things that we have. And if you have to find out the number of solutions, is simply the dimension, find the cardinality of f and the to the power nullity of a. Okay, this is one thing. These are the things that we have to keep in mind and proceed further, right? Okay, let us deal the first option now. For the first option, a can be any matrix. Okay, let me take a to be equal to 1 and 0. Let me choose b to be equal to 1 and 1. So here, note that rank of a is 1. Okay, that is 1. This is a matrix of order 2 by 1. Okay, and my rank of ab, that is what, 1101. The rank is 2. Therefore rank of ab is not equal to rank of a. Hence this is a wrong answer. Okay, a is given to be m by n matrix. It is not given that a is a square matrix. So a can be any matrix of any order. So I have identified one such matrix such that it is not true. So it cannot be true in general. Okay, in the second it is given that ax is equal to 0 does not have a solution. If we are talking about the system of homogeneous equations, it always has a solution, because when you choose x is equal to 0, that is the solution always. Here does not have a solution when x is not equal to 0. If it is given, so then we'll have to examine. Okay, this condition, this restriction was not imposed. So x is equal to 0 is has a solution, that is x is equal to 0. Hence this is also a wrong answer. Okay, and in the third it is given that ax is equal to b. If it has a solution, then it is unique, right? So we can make use of this ideology. It is said that it has a solution. So what? Rank of AB is same as that of rank of A, which is nothing but n, which tells us the nullity is 0. When the nullity is 0, the number of solution is cardinality of f to the power nullity of A. Cardinality of B anything. You are raising the power to A, which means number of solutions is 1. We are done, right? So when we identify the right answer, we can move to the next question in the examination. But to gain the ideology, let us work out the fourth option as well. Okay, here, here, notice that. Okay, we'll have to recollect few things. That is, rank of A is same as that of rank of A transpose. This is one of the ideologies that we have to remember. Okay, and in this problem it is given to be equal to n. Okay, if you try to identify rank of nullity of A transpose, this is what, rank of A transpose plus equal to dimension of the codomain, sorry, domain, right? So when you write A transpose, this is defined from Rm to Rn, so which is m. That tells you that nullity of A transpose is equal to m minus n, right? So the nullity is m minus n. Therefore the solution, number of solutions, if you have any equation with this A transpose, okay, suppose, let us suppose A transpose y equal to b or 0, whatever, to which we are talking about. Okay, number of solutions is going to be cardinality of f to the power m minus n. When can be the solution? Uh, when can the solution be unique? When this m minus n is 0. Okay, the solution to A transpose y is equal to b is unique if m is equal to n, so that we will get m minus n as 0. Here, if you have to get for some non-zero y this is happening to be true, then what? You must have m is equal to n. Okay, this is not the case here. So this cannot be true in general. Right? Now, we are coming to the next question. V is given to be the space of twice differentiable functions satisfying these things. Here, what can be the auxiliary equation to that? That is m square minus 2m plus 1 is equal to 0. When you solve it, you will get m is equal to 1, that is coming twice. Okay, so you can write your function to be c1 plus c2 x times of e to the power x, right? Let us differentiate this one. So when you differentiate, you would get c1 e to the power x plus c2 x e to the power x plus c2 e to the power x. We'll have to make use of product rule here. So this is c1 plus c2 e to the power x plus c2 x e to the power x. Now, what is t of f? Which is f prime evaluated at 0 and f evaluated at 0. If you evaluate, what is the thing that you are going to get? C1 plus C2 comma C1, right? This is what we are going to get. Okay, now we'll have to examine what kind of mapping this T is. Okay, whether it is 1 1 or on 2, all those stuff, for which let me evaluate kernel of T. Kernel of T is what? That is all those functions which are taken from V such that T of f is 0. That is functions in V such that C1 plus C2 comma C1 is 0. When you solve this, what is the thing that you are going to get? The 0 is not simply a 0, this is a 0 vector in R2, which means 0 comma 0. The order pass 0 comma 0. From this, what I am going to get is C1 plus C2 is 0 and C1 is 0. Okay, so if you put it in a matrix form, this is what you are going to get, and this matrix has rank 2. Hence, the homogeneous system has a unique solution. That is C1 and C2 is 0. So when this is the case, you are getting your kernel to be equal to 0. T is basically a linear transformation. Linear transformation is basically what? It's a homomorphism. When a homomorphism with kernel, if a homomorphism is having a kernel that is a trivial thing, then this implies T is 1 1. Okay, this very well tells us that T is 1 1. Okay, now we shall apply rank nullity theorem. By rank nullity theorem, we have rank of T plus nullity of T is equal to dimension of V. Okay, it is given that what is the dimension of V? It is the space of twice differentiable functions satisfying these things. In order to write all such functions, we need only two functions, that is e to the power x. Okay, this V can be spanned with two functions, that is e to the power x and x e to the power x. Hence, the dimension is 2. You know the nullity is 0 by this. Therefore, the rank is 2. What does this rank mean? That is the range space. So, your range of T is actually isomorphic to R2, right? So with which what can you conclude? If this is the case, if the range, okay, actually that is dimension of V is same as that of dimension of R2. This is possible only when T is onto. Hence, it is both 1 1 and onto. Right? So, these are some basic ideologies that we have come across. But during the examination, you have actually, by simply looking at it and finding this T of Fs C1 plus C2, you may be wondering how to find this is 1 1 and how to check whether this mapping is 1 1 and onto. We may be wondering how to check, but there are plenty of options. I am giving you only one option. I'm not telling this is the only way in which you have to do all these calculations. You can do this calculation in any way you want. If you want to do like just by applying the definition of 1 1 and 1 2, yes, you can very well do it, and you check such functions exist or all these stuff. Here we are dealing one thing is a function space, another one is the real plane. So taking an element from real plane and trying to identify one such function that is existing in the function space to verify onto will be quite difficult. So that is why we look for other options that may be handy, right? Now let us move to the next problem. uh, this is one of the most easiest problem that is ever asked in net examination. A polynomial of odd degree with real coefficients. So polynomial with real coefficients, we have some basic results. That is irrational roots occurs in pairs. Okay, I think I have enough space, so I'll write here. So irrational roots occurs in pairs. In a similar way, complex roots occurs in pairs. Since we have real coefficients, I am talking these things. A polynomial of odd degree. So, if it has to occur in pairs, this will take two roots, right? So, odd degree means, let us consider, for the simplicity, let us have okay, alpha x plus beta is equal to 0. Let this be a polynomial of degree 1. So in this case, what is going to be your x? It is minus b upon alpha, where alpha and beta are real entries. So your x is turning to be real entry. Okay, and let us consider the case when alpha x cube plus beta x square plus gamma x plus delta is equal to 0. If suppose uh, it has a complex root, suppose it has a complex root, then a plus ib and a minus ib is two solutions. The remaining, the left out one solution cannot be complex. It has to be real. If it cannot be complex, then it has to be real. Okay, whatever may be the order of a polynomial that you take, very well it is going to have at least one real root. There is no guarantee that it will have all real roots, because this x square plus 1 multiplied with x, uh, consider this one. Okay, this very well has a complex root, but it has one real root as well. Okay, there may be situations where you have everything real root. Okay, but this is some case. Here also at least one real root is satisfied. Okay, so that is the most appropriate one. Now moving to the last question. So it is given that the row space of this 20 by 50 matrix has dimension 3, which means rank of A is 13. Okay, be it a row space or a column space, that is rank. Okay, what is the dimension of the space of solutions of Ax is equal to 0? So basically it is asking for the dimension of set of x such that Ax is equal to 0. So this is what? That is the nullity of A. By rank nullity theorem, what are we going to get? Rank of A plus nullity of A is equal to the dimension of domain. So A is given to be a matrix of order 20 by 50. So A can be treated as the mapping from R50 to R20. So it is dimension of R50. We know the rank is 13, nullity is to be found, and this is 50. So this gives you nullity of A is 50 minus 13, that is 37. So hope you guys have had a good understanding of the problems and the underlying concepts in it. Try to apply these ideologies in the problem that you get, or try to make problems by your own and try to solve it. So that is the best way of getting prepared for the examination. Thank you and best wishes.